Hello, everyone. My name is Kendall, and today I'm sharing with you the results of my biology research project, where I studied the relationship between light pollution, noise pollution, and nocturnal environments. I titled my project Light Pollution and Nocturnal Animals. What is the relationship between artificial light levels and the frequency of nocturnal animals in different environments? I basically wanted to find out if the amount of light pollution correlated with the nighttime sounds that I would hear. Would I hear more animals in darker locations, or would I hear more? What other sounds would I hear? I didn't want to put all of the information on the slide because I was afraid it would make it too wordy. So instead, I'm going to tell it to you. Light pollution is the presence of artificial light in the environment at night. It's usually caused by streetlights, buildings, and vehicles. And this type of pollution disrupts the regular darkness, which many nocturnal animals depend on for hunting, mating, and communication. Nocturnal animals like frogs, crickets, and owls have evolved to be active at night when there is less competition or reason to feel threatened. It's probably where that phrase night owl came from. They often rely on sound to communicate in the dark. For example, male frogs call to attract females, and crickets chirp to signal mating readiness. Artificial light at night has been shown to affect these behaviors. Studies have found that frogs call less frequently or stop calling altogether in well-lit areas. Some bird species begin their dawn songs earlier when exposed to artificial light, and these changes can affect reproduction and survival rates. Like basically, it can mess up their whole lives. For this project, I developed the hypothesis that areas with more light pollution would also have more noise pollution, and that these factors together could disrupt nocturnal animals and their habitats. I wanted to see if darker places with lower Bortle class numbers would be quieter and maybe therefore more suitable for nocturnal animals. To test all of this, I chose like a myriad of locations, and not all of the locations that I ended up going to were locations I had originally planned. Like some of them got switched out. There were a couple I didn't go to that I had planned, but some that I did go to that I didn't have planned. We went from like the rural wilderness to big cities between the Midwest and Canada. My goal was to capture a gradient of light level pollutions from class 1, which is the darkest, to a class 8, which is very bright. I recorded data at each location for 1 hour from approximately 10 p.m. to 11 p.m., just to keep the time consistent and avoid any variability due to the time of night. At each of the locations, I recorded the date and exact location down to the GPS coordinates, which the GPS coordinates, they didn't really matter in the grand scheme, but I just thought they were neat to have. I also recorded the Bortle class level, a description of the area, like if it was farmy or more city-like, or maybe a little bit of both. The current weather conditions for the night and the noise level for that night. This very easily could have been another one of those text-heavy slides, and it still kind of does have a lot of text in it. But I thought it was very important for you to know what the Bortle class scale is. Basically, in short, in 2001, John Bortle developed a scale to rate the levels of brightness at night. Level 1 is the darkest of the dark, and level 8 is really bright. Think like New York City, like a city that never sleeps. Las Vegas, those are definitely level 8s. It really didn't take many supplies to do these observations, thankfully, because we were traveling. I'm incredibly picky about some things, though, so I did choose to take down all of my notes and observations in an actual lab notebook. Other supplies I used were like my iPhone and my iPad, my list of locations. I downloaded a decibel meter app, and then, of course, the weather app, calendar, and a flashlight. When it came to the locations, like I said, my husband and I had already planned to do some traveling, which really helped because I wanted to get like a vast difference when it came to the locations. I didn't want them all to be in like the Polk County, Minnesota area. Um, So we started out in Nebraska. We ended up back in Minnesota. At one point, we did go over the border into Ontario. If if I continue this project, I would really like to try some other areas. We do have family on the East Coast, so I think it would be neat to carry out the same tests like in Virginia. Maybe go to Nashville, try Tennessee. Um, yeah, so we went into a bunch of different locations. My favorite of all of them was Boundary Waters. So, another kind of text-heavy slide here, but this it really is a good read. It details the locations, temperature, the ambient noise sound levels, and the Bortle class scale level. It also clues you into Boundary Waters being one of the darkest sites with a Bortle class of 1 and a noise level of just 25 dBA. On the other end of the spectrum, we had St. Louis, Missouri with a Bortle class of 8 and a noise level of 52. In my lab notebook, I also detailed the notes of what types of animals I was hearing, everything from frogs, which were in nearly every location, crickets, a couple coyote calls, loons and boundary waters, and owls. I was a little surprised I didn't hear more of a variety of animals in the more rural areas, but I'm almost wondering if that's related to the time of the year that we're in and the heat levels. I plotted light pollution against noise pollution for this graph. The x-axis shows the Bortle class, and the y-axis shows the noise level in decibels. Each point is labeled with its location. The graph shows us a trend that darker places tend to be quieter with their man-made noise, and the brighter places tend to be a bit noisier. When I averaged the noise levels by light levels, the pattern became pretty clear. Class 1 had a 25 dBA, class 4 had 3.56 dBA, and then, class 8 with 52 dBA. There were some exceptions like Nebing, Ontario, which had moderate light pollution, but really low sound levels, which, fun fact, they actually have a noise ordinance. After a certain hour at night, man-made sound has to pretty much all but cease. The nighttime sound levels there, like the animals and insects, were what I would say like a proportionate level, knowing that they have a noise ordinance. What I gathered from this whole thing is that as human activity increases, meaning human sounds too, as well as artificial light, the natural sounds of nighttime are disrupted. Some of the challenges that I encountered doing this project they were odd, but they weren't like they didn't throw off the project. It was surprisingly hard to find locations that were a class 1 and 2 level darkness. It was also incredibly difficult to piece out what some of the sounds were, especially in areas where there were a lot of man-made noise. And finally, the weather conditions could really screw it up. Like, if it were cloudy, I didn't hear very many animal sounds. If it were raining, I didn't hear very much animal sounds besides the rain. So I tried to keep it consistent where it was nights that were clear and not windy, not rainy, like just a clear summer night, which was difficult. But I wanted it to be that way across the board. Overall, my hypothesis was supported. Areas with less light pollution also tended to have less noise, indicating lower levels of human disturbance. This project showed how light and noise pollution are linked and why protecting dark, quiet places is important for wildlife. They need their nighttime just like we need our daytime. They need their daytime just like we need our nighttime. So it needs to be quiet for animals too. In the future, I'd like to measure actual animal activity at these sites. And of course, like I said, I'd like to do it at other sites too to see if there's a measurable difference in species presence or behavior based on light and noise levels. Thank you for taking the time to go over this project with me. I hope maybe you learned something, or at the very least, you've been inspired to get out. outdoors and listen to nature, maybe see a bunch of stars.